Okay, we're back and we're ready to start talking about motor starters. Okay, this is what we're going to really use to control the motors. The last segment of the lesson we talked about our ladder logic and our rails and our rungs, and really the only output device that we had on that was just a light bulb. Okay, that was just to illustrate and kind of show you an example of the ladder logic and the rungs and our input devices and our output devices, but we really don't want to control light bulbs all that much. What we're trying to control is three-phase motors, what this is all about. And remember, we want to start them, we want to stop them, we want to jog them, we want to reverse them, kind of control the speed of them. So that's what we're going to do now, is we're going to talk about the devices that are critical to doing that, and those are motor starters. Okay, got a couple different kinds here. That's a square D on that end over there. This is an Allen Bradley Bulletin 509, very popular one. It's still available, and this is one you're going to be using and tearing down in the lab. And this is another more recent generation, or current generation of Allen Bradley starter as well. I like the 509 because we can disassemble it. This one is completely encased. We can't take it apart. But these two right here, you can disassemble, and we're going to disassemble one of these because I want you to see the inner workings of a motor starter. It's one thing to say, okay, the motor starter is bad, but if you understand how it works, it's a lot like the power in the motor. You've got to understand what it is that's going on, what we're controlling, okay, what we're working with. So I want you to understand the ins and outs of a motor starter. Okay, it's going to be very helpful for you when you start moving into troubleshooting and things like that. Okay, I think you'll enjoy this lab too. I think the students really enjoy this. Okay, let me just kind of show you. I've got the 509 here with me, and so here we got our 509. Okay, and we're going to go over each one of the components that we're going to talk about. And again, this is an Allen Bradley, very popular. Okay, so let's start talking about some of the components first. Okay, and I'll try to hold this one up for you so you can see it as we go along. Okay, so the motor starter components, we have two sides of a motor starter actually. We have got the motor or power circuit components and the control circuit ones. Okay, first we're going to start talking about the motor or the power circuit component side of that motor starter. Okay. First of all, we have the three-phase line lugs. Incidentally, this is the phase symbol. This symbol represents phase. So when you see that, that's phase. So it's a three-phase. If it had one, it'd be a single phase. Okay. But this is the three-phase line lugs. Okay. This is where the voltage comes in from our three-phase power supply, and on this 509, they're right here on top. Okay, so we will feed our A, B, and C, or our L1, L2, L3 phases right here. It will you strip the wires back on the conductors, you just kind of slide them in there, tighten the screws down, and that's where we start feeding the voltage into the motor starter right here on these line lugs. Okay, and the next thing, now you can't see these in this video right here, but you'll see these when you come to into lab. You'll have the three-phase contacts. Okay, they're different from some other contacts inside the starter, so keep that separate. We've got the three-phase contacts. You got the overload elements. Okay, we can see those. We've already talked about overloads. These are our overcurrent protection. This helps us protect the windings of the motor, not short circuit protection. Okay, not overcurrent protection, but overload protection. Okay, these are the devices right here. This is just particularly one type of heating element. Okay, that goes in here. But anyway, so there's our overload elements, okay? And incidentally, that's where we feed the three-phase voltage going in. We have the lugs, the three-phase motor lugs. We will hook our T1, T2, and T3 leads to the motor right here. So our voltage basically comes through here, into here, passes through the motor starter, goes through the overloads and make sure it's protected, and then on out to our motor. Okay, so that's basically the components for the three-phase side for the power or motor circuit. Okay, now basically the motor starter's job is to apply and remove three-phase voltage to the three-phase motor. Okay, and it does this by closing those opening and closing the set of contacts in the motor circuit. Okay, so there's three of them because it's three-phase. All right, so let's take a look at our schematic, how it kind of plays out. When I'm talking about the motor contacts, okay, the contacts inside the motor starter, okay, that's in the three-phase power section, okay, that's right here. Okay, now these look similar to the ones that we looked at in the manual motor starter. Okay, they should, because in the manual motor starter, when we wanted to close the contacts here and allow the three-phase voltage to pass through to the motor and make it run like you did in the lab, we manually closed these. We pushed them and physically pushed these contacts together, and all three of them at one time, and we fed our motor three-phase voltage. Okay, well, we don't do that with a motor starter. Okay, this is a magnetic motor starter, and there's something that's not listed on here. It's called an across-the-line starter. Okay, both the manual and the magnetic are across-the-line starters. Manual and magnetic are the two different types of across-the-line starters. So we're working with magnetic across-the-line starters, and you're going to see why we call that, why they're called magnetic shortly. But anyway, what we're doing is we are, like the manual, we're closing these set of contacts to feed the power. Okay. Also, as I stated earlier, the starter or the motor starter has overloads in it. Okay, it's part of the entire package. Okay. Have overloads to protect the motor windings from an overloaded motor situation. Okay. All right. Now let's move to the control side of the motor starter. Okay. The circuit components will be wired into the control circuit. They're not wired together in any way, shape, or form in this motor starter. They're completely separate circuits. Okay. For the control circuit components, we have the coil. Okay. And remember, a coil, and I've said this a gazillion times, a coil is simply one piece of wire wrapped around a gazillion times with a beginning and an end. And we put voltage on there and we create a magnetic field. And that's where the magnetic motor starter starts to come together, okay? So this is the coil. I'll kind of get a little close up, I think, if I can. This is the coil. This is the beginning. We're going to talk about this red wire a little bit later. Just kind of ignore it right now. But we've got this, the beginning of the coil wire, and this is the end. So this is where we apply our control voltage, not the three-phase power voltage. This is where we apply the control voltage, okay? And every magnetic motor starter has a coil in it. Not a manual one, but every magnetic motor starter has a coil in it, okay? We have an armature that you can't see right now. You will see the armature when you take it apart in the lab. And we have normally closed overload contacts, okay? Now that is not the overloads for the power circuit, okay? That's not normally closed overload contacts are not the overload devices themselves, okay? They're not the bimetallics, okay? Or the thermals. They are a completely separate set of contacts, okay? And they're off to the side right here. Kind of hard to see, I know. But they're a completely separate set, and they are only in the control circuit, not the power circuit. And then we also have a normally open auxiliary set of contacts, and it's difficult to see those as well. I'm trying to see if I can get you to see these, but they're off over here to the side as well. It's difficult to see those, but you'll see them in lab when we start tearing everything apart, okay? So, this is the control circuit components of the starter, and this is the power or motor circuit components of the starter. So let's see kind of how these marry together, how they work together in order for us to start and stop this motor, okay? So again, we've got our control circuit. We're on rung 1. This is wire number 1. We're going to push the push button, and instead of a light, now we are going to energize the coil of the motor starter. So if I were looking in a cabinet, for example, if I were looking at a cabinet and I saw from my push button went to the motor coil, okay, I should find wire 4 coming to the terminal on the coil of my motor starter. We talked about the wire identification numbers. That's why it's so important. If I'm looking to make sure that I get to the right component, wire number 4 for this particular motor starter is labeled wire number 4. I should go to this particular motor starter. There may be 50 motor starters in the cabinet, but this particular one will be labeled M1 because we're trying to start motor 1. This coil right here should be labeled with a wire coming in with a number 4 going to it. Okay, so that's the coil going. We're going to energize the coil. Instead of turning the light bulbs on, we're going to turn a motor starter coil on. What happens when we energize that coil? Well, let's back up and look and see what a coil does first. Okay, so we have a coil, and I got a better picture here. Okay, we got a coil right here. And again, a coil is nothing more than a piece of wire wrapped around some type of a core, you know, and when we apply voltage to it, we create a magnetic field. All right, now the parts of our coil, coil and contacts in the starter, we have stationary contacts that do not move. Then you have this tie bar up here that's attached to the armature. Remember, the armature is made of iron, so when we create that magnetic field, that armature pulls down into the magnetic field. Well, it drags these contacts here with it, okay? And we have a 408 volt supply right here. This is just one phase. We have one coil, but it will control 3 different sets of contacts. I'm just looking at one right now for our example. So we've got 408 volts basically going to our L1 lug right there, okay? And then it's wired to the stationary contacts. When we energize that coil, okay, when we energize that coil, put 120 volts on our coil, that magnetic field pulls that armature down. And when it does, it pulls this tie bar down with the moving contacts, and it bridges the gap from the 480 on out to the motor, okay? Now, again, this is just one phase. One coil will handle the 3 phases, but I'm just showing you one at this time. You would have 2 more phases going to the 3-phase motor, but it would pull them all simultaneously at the same time. It would pull them down at the same time. The moment that we created that magnetic field, it pulled that iron armature into its path, okay? So as a result, this is our control circuit. I push the start button right here, our normally open push button. I push that and I hold it, and we energize that coil. And in doing so, pulling that armature, it closes these contacts. Now our 3-phase voltage is allowed to pass through our overloads and onto our motor, okay? And that's what happens when we energize this coil. We create that magnetic field, hence the magnetic motor starter, okay? So so far what we've done is we've energized the coil and we close these contacts. And again, all of this is going to come a lot more clear to you when you get to take a starter apart and then put it back together and test it, okay? Now another component is the overloads, okay? Now there is another set of contacts in here on the starter, and I showed them to you earlier. It's kind of hard to see, I know, but these normally closed. It's labeled NC right here, normally closed, okay? That's what this set of contacts is right here, is normally closed contacts, and it's on the starter. Again, this is in the control voltage, I'm sorry, the control circuit. This is in the power circuit. So let's talk about how this works. When we are running along, and say our motor gets bogged down, we're running it too hard, and you saw it in the lab, you tripped it out in the lab on an overload. So we're running along, everything's fine. This is normally closed. My control circuit's complete. I've got some power flowing through my coil. I'm going back to neutral. I'm going through these normally closed contacts. Everything's fine. I've got a completed circuit. Let's throw our motor into an overload situation, okay? So I've loaded my motor up. I've got too much on my conveyor. I've got boxes jammed on my conveyor. My gears are something went into the gearbox or something that's locking everything up and it's causing a strain on my motor. My overloads are going to kick open, okay? They're going to open up as you saw them do over there, okay? And when they do, when they open up, they'll pull the 3 phases of voltage off of that motor, the motor quits running, okay? At the same time, in the control circuit, there's a mechanical linkage between these 3, not electrical, but a mechanical linkage between these 3 overloads in this normally closed set of contacts, so that when these separate to protect the motor, it also opens up this set of contacts right here, and it disrupts our path back to neutral. Okay, if we don't have a path back to neutral, the control circuit dies, and we want it to die because we got an overloaded situation here, and we don't want to sit here and energize this coil over and over and over trying to get it to restart. What we do is we not only disrupt the 3-phase voltage with our thermal overloads or our bimetallics, okay, or whatever form of overload we have in the circuit, but we also open up that control circuit by opening this set of contacts. When these open up, it yanks this set of normally closed contacts, and now this is open, and our control voltage stops right here. It can't make it back to neutral, so we don't have a complete circuit. The coil de-energizes at that point, okay? So it's very important that you understand that, number one, there is a mechanical linkage between these sets of contacts, but no electrical. Remember, these are in the power circuit, and these are in the control circuit. And the reason I'm hammering on this is because in my past experience with teaching this class, students have difficulty keeping these 2 separated, and I will often come to check their wiring and find that they've got 3-phase trying to fire off a coil. No, these circuits do not meet whatsoever, okay? They're only joined through the transformer, okay? And as you remember, The primary and secondary are not wired together. So there's no electrical connections between these two. It's through mutual induction that we have the power coming out. But my point is, with these overloads, when they open up, they open this contact and they affect the control circuit as well, okay? So I hammered that a little hard, and so appreciate you bearing with me on that one, okay? So so far what we have dealt with in our control circuit is a two-wire control circuit, okay? Basically you have two wires. You have the incoming and your outgoing of a switch, okay? And we call that a two-wire control system, okay? Now, I want to back up here. We're fixing to go into a three-wire, and to have that, we have to have auxiliary contacts. Now, we talked about the auxiliary contacts right here. They are normally open set of contacts. I don't know how well you're going to be able to see this, but this is a normally open set of contacts right there. Okay, when that coil gets energized, we close the three-phase voltage, okay, the three-phase contacts to provide voltage to the motor. We also close a set of contacts on this one right here too, on this normally open set. So this, when we energize the coil, this normally open set of contacts closes, okay? Now, what are we going to do with that? Well, you can do several things, okay? Normally open contacts are mounted on the motor starter, okay? They're considered an input device. I'm going to show you that in the ladder diagram. And they are used to control auxiliary components such as lights, alarms, or whatever. Some indicator light that says that the motor starter is energized and the motor should be running. Okay, maybe we hook it to a green light or something like that. But, okay, they're also used as seal-in circuits. So we're going to get to that in just a second. They're to maintain an energized circuit anytime the momentary push button or momentary input device is released. Okay, and they are never, ever, ever used in the control circuit, or the motor circuit. They're only used in the control circuit, never in the motor circuit. This is a very, very small, lightweight set of contacts. They are not built to handle the current going through a motor. Three-phase motor, control circuit, okay? So, keeping those separated. They're in the control circuit only, all right? So let's take a look at this on how this works, all right? So, now, I've also introduced rung number 2 in our ladder diagram, all right? So what we've got here, we've got our, we're going to energize our coil, and everything's going to be great because we're not in an overload situation. So the moment that I energize this coil, okay, I may have that on the next one. Nope, no. So the moment I energize this coil, we said that these contacts close, the motor starts to run. Okay, this is also, you'll see the M1 designation and the M1, that means that these are the contacts that are on board that motor starter, okay? So when we energize this coil, we also close this set of contacts. We have this 120 volts coming up to it, all right? And the moment that we press our button to energize this coil labeled M1, we're going to close the contact called M1. Those are the ones that are on board the motor starter, and they're going to close. We're going to come over here and we're going to turn a light on. Okay, I'm just using this as an example of what we can use these, one way that we can use these auxiliary contacts. Again, these are auxiliary contacts, normally open. We energize the coil, it closes, and a light comes on. Let's back up and look at our numbering system while we're at it, okay? Again, 1 here, going into the switch, the little connection point, 1 going into the contacts, okay? That number 1 is going here to this, screw terminal here on the top side of the contact, okay? So we're going to have power, 120 volts sitting here resting, waiting, okay? The moment we energize it, these contacts close, power will then go to the light. So in other words, we're going to have 120 volts coming to this screw. The moment this energizes, okay, the moment the coil energizes and pulls the contacts in, it closes. The wire going to that light right over there in our schematic, the light, it will light up, okay, provided we got a neutral and everything like that. But this is where the contact closure happens to make that light come on, okay? That's just one way you can use the auxiliary contacts. Now, make sure that we don't confuse them with the overload contacts. Both sets of contacts are on board the motor starter, okay? The overload ones are monitoring the overloads, and the moment that we have an overload, they open up. That's one set. But the normally closed is our auxiliary set, and we can use that for a couple of things. In this example, we are lighting up a light. Okay, let's do something a little bit more with it in just a second. Uses the normally open contacts on motor starter to maintain an energized circuit after the momentary input device has been released, okay, such as a push button, okay? So what we want to do is we want to push that button and walk away, okay? So let's use our set of contacts as a seal-in, okay? And this is a 3-wire control circuit. You have your 1, your 2, and your 3. That's considered a 3-wire control circuit. You can read about that in your textbook, but this is how this works. And this is kind of throws a lot of students off, so I'm going to kind of hammer it just a little bit, all right? So again, we also said that, that input devices could be wired in parallel or series. If you go back to that first segment that we talked about, input devices, we said they could be wired in parallel or series, okay? Parallel only for output devices, either or with the input devices. So that open set of contacts is an input device in this particular case. So let's talk about what we've got so far. I've got the power coming out of the transformer. I'm coming up to my switch right here. I've not pushed the switch, and there's a connection point right here, and it's got power waiting on our contacts right there. Just sitting there waiting. We're not doing anything really. And so now I'm going to press that button, and voltage is going to pass through first to the motor starter, okay? And that coil is going to energize, okay? It's going to go to our neutral, it's going to energize, and when it does, the armature is going to pull down, pull these 3-phase contacts, and with it is going to pull this auxiliary set of contacts closed. By doing that, it gives us an alternate path to keep the motor starter coil energized, okay? So now we've got this path through our switch. You'll have to pretend with me that I've got my button pushed. I've got my button pushed, I've got one path established. Now these contacts are closed because this is energized. I have a second path to keep my starter energized, okay? So now I can let my button off, and I'm still maintaining this path here, okay? One path died out on me when I let the push button go, but I still have a maintained path right here, okay? It's called memory logic. That's one way, one term that they use to describe it is memory logic, okay? But we call it a 3-wire control circuit. So now I can let go of my push button, the start, we could call this the start button, and I can let go and I can run all day long, okay? 2 things will stop me from running, okay? Number 1, we overload, and we pop those open, opens this circuit right here, and boom, I no longer have a path back to neutral. So my circuit dies completely, okay? And we wind up back to that, okay? The other thing that could take our circuit out is everything's running along, just we're fat, dumb, and happy, everybody's happy. So what we can do is we can open the circuit back here, and when we do, it'll kill the circuit from here on down, okay? I didn't do a real good job on the graphics with this, but you get the idea. We can kill it through the E-stop by killing the power going into the memory circuit. And once it's opened up this energized coil, once it becomes de-energized, this opens back up. We have no path back to it, so it dies, okay? And in the process, it opens these contacts, and our motor shuts off, okay? So there's a couple different ways we can open that circuit, all right? So that is motor starters, all right? I think at this point I'm going to stop because the next thing we want to talk about is control relays. Very similar animal, but I want to stop right here and just kind of break it up at this point. So again, I hope you're taking notes, and if you are, and write down questions that you want to ask me. Okay, but we're going to tear apart some control relays also, but we're also going to take apart some motor starters. So let's just call it good for that, and then come back for the next phase of this lesson, and we'll be talking about control relays. Okay, thanks a lot.